This is Forces Lesson 8, and this is momentum. Quite a straightforward one. So the objective is to describe what momentum is and make momentum calculations. So momentum, which we use the letter P, which might seem a bit strange, but momentum is mass times velocity, or P equals mv. Momentum is a vector, its direction is extremely important. So mass is measured in kilograms, velocity is measured in meters per second, which you should already know. So if you want to pause and try and figure out what momentum might be measured in itself, you can do that. I'll say what it is now. So momentum is measured in kilogram meters per second, which if you wanted to figure that out, you could write P equals, and then it's mv. So instead of putting mass times velocity, we'll put the units instead. So kilograms for the mass and meters per second for the velocity. So momentum is measured in kilogram meters per second. Remember to pause if you want to write anything down. So momentum has both magnitude and direction, and it is in the, its direction is the same as the velocity. So whichever way it's traveling, that's the direction in the momentum. So, for example, the greater the mass of a rugby player, the greater is his momentum. Or if he runs faster. And if anyone knows who that is, that's used to play for New Zealand, called John Alomo, one of the best ever. And he had a lot of momentum, because not only was he really heavy, he had a lot of mass, he could also run extremely fast. Let's move on. So let's get straight into it. So nice and straightforward. So first of all, calculate the momentum of a rugby player of mass 120 kilograms moving at 3 meters per second. So I'll go for the answer now. So P equals mv. So the momentum is simply the mass times the velocity. So for this one, it's 120 kilograms multiplied by 3 meters per second. And 120 times 3 gives us 360. And the unit, remember, for momentum is kilogram meters per second. Let's move on then from there. So on this one, if you want to pause and have a go. Calculate the mass of a car that when moving at 25 meters per second has a momentum of 20,000 kilogram meters per second. So, equation, momentum is mass times velocity, P equals mv. So the momentum is 20,000, so 20,000. If you're good at maths, you could write, well, not necessarily good, if you've done standard form, you could do 20 times 10 to the 3 equals mass of m times velocity 25. So as always, we're going to make m the subject, so we need to get rid of the times 25. So we need to do the opposite operation, and the opposite of timesing by 25 is dividing by 25. So the mass is 20,000 divided by 25, so that's 800 kilograms, which actually is very light for a modern car. So that would be some kind of kit car or on a track weight reduction. A typical family car now might be 1,600 to 2,000 kilos. If you've got a big SUV, 2,500 kilos maybe. So this is a small one. Right then, complete this. So if you want to pause and have a go. Let's have a look at some answers. So the momentum, the first one, momentum is mv, remember. So 50 times 3, so that should be 150 kilogram meters per second. The second one, so number 2, I'm just going to put some working out at the bottom. So P equals mv, so that'd be 160 for the momentum, is equal to the mass, which we'll call m times the velocity of 20. So to get rid of the times 20, we need to divide by 20. So 160 divided by 20 is simply 8 kilograms. So next one, so third one. So that would be momentum equals mass times velocity, so 1,500 equals the mass of 250 times v. So to get v, we need to get rid of the times 250. So that's 1,500 divided by 250 kilograms. So that gives us 6 meters per second. Next one, be careful. Hopefully you've spotted this one, 500 grams. So grams into a kilogram is 1,000, so 500 divided by 1,000 gives us 0.5 kilograms. Then it should be straightforward for the momentum. So number 4, momentum is mv, so it's just 0.5. times 8. Half of 8 is 4 kilogram meters per second. So this last one, we need to be careful with this one. So we need to convert this 50 centimeters per second. 50 centimeters per second is obviously, well, there's 100 centimeters in a meter. So that would be, the conversion would be 0.5 meters per second. So then it's P equals mv. So the last one, number 5, would simply be 3 for the momentum equals mass times 0.5 for the velocity. So then to get mass, we need to get rid of the times 0.5, so divide by 0.5 on the other side. So that's 3 divided by 0.5, which gives a mass of 6 kilograms. Hopefully that all went okay. And that's it for the introduction. So there's 2 more lessons for momentum. They do get, the third one is definitely significantly harder. It's quite a lot of explanation stuff in the next one, so make sure you check them out. Thanks for watching. I'll speak to you soon.